Hello students, I am Sailesh Prajapati. Today I explain you chapter number 4 in the second part. In first part students I explained the basic definitions row wise. Here today I explain to the various types of properties of the determinants. So in determinant total are the 6 properties. So one by one I explain in this video. First of all, property number 1, the value of determinants remains unchanged. Unchanged means they're the same. If the row and columns are interchanged their corresponding elements. So very easy. First I explain to simple one of our determinant taking. Suppose one of the del I will take here to any A1, B1, C1, A2, B2, C2 and A3, B3, C3 and expand by the definitions. So del value known that A1 minus B1 and the C1. If you take here L shapes B2, C2, B3, C3. Similar T shape A2, C2, A3, C3 and last L shape A2, B2, A3, B3. Now very easy, you just expand it. So del I have A1 B2, C3 minus B3, C2. Similarly, you're going ahead, the second expansion's value to A2, C3 minus C2, A3 and last A2, B3 minus B2, A3 and just expand. So your del value is A1 B2, C3 A1 B3, C2 minus B1 A2, C3 plus B1 C2, A3 and last C1 A2, B3 minus C1 B2, A3. This value you will take, that is equation number 1. Now I will operate to that corresponding rows and columns are interchanged. So if Ri tends to Ci, students, Ri means all row converting into all columns, where I will indicate I become 1, 2, 3. In shortly you will take also R1 tends to C1, R2 tends to C2 and R3 change to C3. It means first row element, this first row element, you will write down the first column. So your new del 1, either del dash, that is the change. First row convert in first column. So A1, B1, C1. Second row, second column A2, B2, C2. Third also same A3, B3, C3. And now expand by definitions. So del 1, A1 with definition is known students. I just write down one direct steps. A1 with these are the multiple with this A1. So B2 C3 minus C2 B3. Second T shapes B1 C3 minus B3 C1 and the end of this B1 C2 minus B2 C1 and last multiply it. So del 1 A1 B2 C3 minus A1 C2 B3, continue, A2 B1 C3 plus A2 B3 C1, A2 B3 C1 and last A3 B1 C2 minus A3 B2 C1. And this equation you will take just statement number 2. Yes, that is step 2. And check both are same. So from 1 and 2, del and del 1 are the same. A1 B2 C3, A1 B2 C3 remains same. That's why the value of determinant remains same if the every entry of row and column are exchanged. Now I go to that related one little examples. verify our property number 1 in the given del. So very simple that. After applying property number 1, the values are same. I just check by the simple example, 6th one. Example 6. Del given 2 minus 3 5 6 0 4 and 1 5 minus 7, and asking that verify property number 1. Very easy. First apply del. 2 minus 3 5 6 0 4 and 1 5 minus 7. So go to definitions first and describe that particular's value that you know. So my first value 2, I have 0 4 5 minus 7, this and that L shapes. Second T, 6 4 1 minus 7, and last 6 0 1 5. Now tell the answer. 0 5 4 is 20, 7 6 is 42, 4 1 is 4, and last end 5 6 5 is 30 minus 0, so it get minus 40. Here minus 46, and that will be 150. So del become minus 40. Here 6 3 is 18, 1 carrying, 4 is 12 plus 1 13, 150, 150, and that is 40, 110 minus 138. So it is minus 28. They become the, either this is a 12 minus 40 minus 24. Now I operate my property number 1. So if I operating that, del 1 you will get, after operating Ri tends to Ci, every row interchange in the column. So you have to clearly new del 1 is that clearly this is your first row. You will write first column. So here 2 minus 3 5, second row second column, and third row third column 1 5 minus 7, and do it solutions very easily and very quickly. Simple. So first L shape write down 0 5 4 minus 7, second 6 minus 3 5 5 minus 7, and last minus 3 0 5 4. Now del 1 you will start now. 0 5 4 is 20, here 21 minus 25, and last one minus 12 minus 0. So what is del 1? It is minus 40, here minus 4 minus 12. Now minus 40, 6 4 are 24 minus 12, it is 12, 12 minus 40 will do minus 28. That is your equation number 2. Now 1 and 2, check, they are same after exchanging every row into every columns. So therefore from 1 and 2, del 1 is equal to del are the our simple entry over here. Now I am moving towards property number 2. Indirectly it is theorem number 2, and that is a different types of prospect at our theorem number 2. If property, if any two row, either column also or column of a determinant are interchange, yes, are interchange, then sign of the value for old determinant is additive inverse. Sign of determinant change, either additive inverse. That is the concept. So very easy. I first write down my first del according to, I explained already theorem 1, property number 1, a1 b1 c1, a2 b2 c2, a3 b3 c3, and that solution also I known that a1 with b1 with c1 with, this is the L shape, b2 c3 minus b3 c2. Second T step, a2 c3 minus a3 c2, and last a2 b3 minus a3 b2. And now you just expand that, the total del is a a1 b2 c3 minus a1 b3 c2 b1 a2 c3 plus b1 a3 c2 c1 a2 b3 minus c1 a3 b2. That is statement number 1. Now this value I now operating to any row interchange, either any two column. So if two row R1 and R2 interchange, it means you will operate R1 change in R2. You also write R1 change in R3, either R2 change in R3. After that you also written that the C1 C2 change, C1 C3 change, either C2 C3 change, as you like. So here your new del 1, this first row and the second row, both are the exchange. So this write down first place, a2 b2 c2 and a1 b1 c1, and that much same a3 b3 c3, and do the expansion by simple definitions. So a2 here minus b2 that, and c2 also same. Value put it b1 c1 b3 c3. Now next T shape, a1 c1 a3 c3, and at the end of this a1 b1 and a3 b3. The simple, you expand it, you will get the additive inverse of the original del value, I mean minus carry outside that. So I simple expanded the values for del 1, it is a1 with, a2 with b1 c3 minus b3 c1. Similarly, a1 c3 minus a3 c1, and c2 with a1 b3 minus a3 b1. Just you multiply inside a2 b1 c3, a2 b3 c1, b2 a1 c3 plus b2 a3 c1, c2 a1 b3 minus c2 a3 b1. You check here, a2 b1 c3, a2 b1 c3 is negative, so I will take minus carry outside. Each have minus carry outside. Minus a2 b1 c3 plus a2 b3 c1 plus b2 a1 c3 minus b2 a3 c1 minus c2 a1 b3, and last plus c2 a3 b1. And this answer is minus 1 of del. from 1. That's why this value is determinant value is a change. So here you are verified your property number 2. And that related I will start now my little examples. Similarly, example number 7. Verify property number 2 for deal given. Verify property 2 for the deal 2 minus 3 5 6 0 4 and 1 5 minus 7. This is already I explained in example 6 minus 20 12. So I just explain about that same again. 0 4 5 minus 7 6 4 1 minus 7 and last 6 0 1 5. It will take 0 minus 20 minus 7 6 are 42 minus 4 and 30 minus 0. It will cover to minus 40 minus 46 150. So it about to minus 40. 6 3s are 18 1 carry 4 3s are 12 plus 1 13. It get minus 28. Now I operate verify the property 2. It means 2 row I exchange about that internally. As you like, you also explain the 2 columns, any 2 columns. So I just verify that. Similarly, in del we interchange R1 to R3. You also interchange R1 with R3. Answer same coming, but the additive inverse minus 28 they get the plus 28. So your del 1 is that first row these are exchange with the second row. So here 6 0 4 2 minus 3 5 and 1 5 minus 7. 6 0 4 upper side, 2 minus 3 5 bottom sides. So my del 1 is 6 with minus 0 plus 4. Now answer 6 I have minus 3 5 5 minus 7. Secondly 2 3 2 5 1 minus 7 2 5 1 minus 7 and the last 2 minus 3 1 5. And you will do it. It's a simple answer. Minus 3 5 7 2 5 1 minus 7 and 2 minus 3 1 5. 21 minus 25. Here 0 permanently because all values 0. Here 10 plus 3. So it will get minus 4 and here 13. Now answer coming 6 4s are 24. This minus 24 and here 13 4s are 52. So del 1 is a 28, but you check that is the additive inverse. So I just write down minus of minus 28. So del 1 is equal to minus del. This is your del. It means here I verified that property wise, that is the simply known. If you any 2 row interchange, then the value of new determinant is a additive inverse of the original. And that is the simple and simple done. Now students, after that I will going ahead our theorem number 4, I mean third one. Yes, after the second theorem ending I go to theorem number 3. Yes. Now students, I continue our property number 3. If 2 row or the column of a determinant are identical, it means the same corresponding value for any 2 row, either any 2 columns, then value of determinant always 0. So here I explain about that simple. We will take the del value for 2 row equal a1 B1 C1, A1 B1 C1, and here student take any two values for the third row, just like A2 B2 C2. So your tail value is A1 minus B1 and the C1 values for corresponding B1 C1, B2 C2, A1 C1, A2 C2, and last A1 B1, A2 B2. So your answer is covered. Definitely it is 0. B1 C2 minus B2 C1, A1 C2 minus A2 C1, and A1 B2 minus B1 A2. Now expand the total. A1 B1 C2, A1 B2 C1 minus B1 A1 C2 plus B1 A2 C1, and last C1 A1 B2, C1 B1 A2. This cancel, all are. Value of determinant is 0. Same going now. Example 8. Evaluate the value by the theorem 3, either property 3. Del is 3 2 3, 2 2 2, and 3 3 3. Very easy. 3 2 3, 2 2 3, and 3 2 3. So here you check your first row and third row is same. Value of determinant is 0. Any two row elements are same, either column. I do first expansion by method. 3 minus 2 and 3, and internal value 2 3 2 3, next 2 3 3 3, and last 2 2 3 2. Decide the value. 6 minus 6, 6 minus 9, and 4 minus 6. You will get 0. Here minus 3, that minus 2. So 6 minus 6, 0. Value of determinant 0. But if I taking by property number 3, yes, also here in another method, del is 0 because two row is same, row 1 and row 3. Row 1 equal to row 3 by two equal rows. Value of determinant is 0 by property third. And here you done that. Now continue our theorem 4. Property number 4. Very easy. So in the fourth one, yes, each elements of row and column multiply by k if each elements of a row or columns or a column of a determinant multiply by non-zero constant is multiplied by a constant k, then its value of new determinants, its value gets multiplied by k. Yes, multiplied by k. So very easy. Here also I assumptions one of the determinants a1 b1 c1, a2 b2 c2, a3 b3 c3, and expansion also you know that very well. A1 minus b1 and the c1. A1 I have this value for directly calculate b2 c3 minus c2 b3. Next a2 c3 same A3 C2, and last word the A2 B3 minus B2 A3, and just you expand it. A1 B2 C3, next A1 C2 B3 minus B1 A2 C3 plus B1 A3 C2, or last C1 A2 B3 minus C1 B2 A3, and that is your step number 1. Now we are given any one row, either column, multiply by k. So if k multiply by row 1, so you also write down that row 1 multiply by k with that this step ahead, and your del 1 is the first row multiply by k, k1 kb1 kc1, other same a2 b2 c2, and a3 b3 c3, and simple, you just calculate by the definitions. Definitely they cover to k time of new determinant value. So it should be simple way your answers. So del 1 is a ka1 minus kb1 and last kc1, and put down their values. K1 is that B2 C2 B3 C3, next A2 C2 and A3 C3, and last of the A2 B2 and A3 B3, that much to KC1, A2 B2 A3 B3. Now calculate. So del 1 is a Ka1 B2 C3 minus B3 C2, similarly A2 C3 minus C2 A3, and last A2 B3 minus B2 A3. Now just you common take k outside, other is definitely it is k, A1 B2 C3 A1 B3 C2 minus B1 A2 C3 plus B1 C2 A3, and last C1 A2 B3 C1 B2 A3, and that should be, it is del from 1. That's why your proofing is done. It is multiple of k times the new determinant's value. Now moving towards our example number 9. It's very easy. Using evaluate in the example number 9. And question is there, evaluate the following del 102 18 36 1 3 4 and 17 36 very easy. No doubt students, it is 1 3 4 same, 17 36, this is the multiple of 7 6 17 6, it is 6 3 and it is 6 6. You just take common outside in the first row, 6 common, 17 6 6 3 1 3 4 73 6, common taking to first row, that's why we will write down 1 by 6 to R1, and these two are same, and two elements for the row are equal. It is 0 because row 1 equal to row 3 by the property number 4. Yes, so your del value is definitely 0. Yes students, here after that example 9 I will stop this video, and theorem 1, property 1, property 2, property 3 and property 4 one more time I revise. In property 1 I explain every row element convert to every columns, value of determinant does not change. Second theorem, any two row interchange, either any two column interchange, value of determinant is a additive inverse. Third, any two row are given same values and the answer 0. And theorem 4 is a multiple times of k. Any one row either column, you will get k times of new determinant. Now here students, I stop this video, and further explanations, theorem 5 and 6, I will explain in the next part. Bye bye.